I hopefully proved to you, at least, maybe it doesn't make intuitive sense just yet, but I showed you, that the probability of A and B is equal to the probability of A given B times the probability of B, and the probability of B given A is equal to the probability of B given A times A, and then we played around a little bit and we got this. And this is called Bayes' theorem or Bayes' law. And I will now show you how you can apply this formula. But it shouldn't be in a formula. You should always be able to intuitively come to this conclusion, even if you forget Bayes' theorem, which I do all the time, and then I go through that thought process that we did at the end of the last video over again. But let's see how we can apply this to this problem. So we want to figure out the probability that we pick the two-sided coin, given that we observed that when we flip it 5 times, we got 5 heads. So let's say that this is event A, and this is event B. Right? So we can use Bayes' theorem. So the probability that I got the two-sided coin given 5 out of 5 heads is equal to the probability, and I'm actually going to think about what this fraction means in a second, but it means the probability that I got A given B. So it's this, the probability that I got 5 out of 5 heads given the two-sided coin, times the probability of the two-sided coin, right? B, we defined event B as a two-sided coin, times the probability of two-sided coin, divided by the probability of, in general, the probability of getting 5 out of 5 heads. The probability of 5 out of 5 heads. Right? Well, what's the probability of getting 5 out of 5 heads given the two-sided coin? Well, we already rewrote that down. We're guaranteed to get 5 out of 5 heads. So that's 1. And what's the probability of getting the two-sided coin? Well, that was 1/10. Right? And now what's the probability of getting 5 out of 5 heads in general? Well, we figured that out, I think either in the last video or the video before that, right? It was, I forgot the exact number. Actually, it was something like, it was 1/10 plus 9 over 320, and right, so this is 32. It was 41 over 320. We figured that out in the previous problem, right? So this is over 41 over 320. And so what do we get? We get this is equal to 1 over 10 over 41 over 320. And what does that equal to? That equals to 1 over 10 times 320 over 41. Let's divide the top and the bottom by 10. So it equals 32 over 41. That's interesting. I actually find that really interesting. I don't know which coin I picked out of the bag, but I know that if I flip that coin 5 times and all 5 are heads, that there's a 32 out of 41 chance, this is maybe a little bit better than a 75% chance, that I picked the two-headed coin, we could say. And let's think about this visually a little bit. So, if this is the entire universe of what could happen, and we said, 1/10 of that, this is the two-sided coin, this is the fair coin. And then out of all of that, the situation in which we get 5 out of 5, well, those could be, well, pretty much all of the, if we got the two-sided coin, all of that is going to be 5 out of 5. And then some small fraction, 1/32 of the fair coin. So this yellow circle represents getting 5 heads in a row. So if I want to know what's the probability of the two-sided coin, all Bayes' theorem is saying is, well, okay, we observed that we got the two-sided coin. We observed that we got 5 out of 5 heads, right? So we now know that we're in this yellow universe, because the yellow universe represents the area or all of the outcomes where we got 5 out of 5 heads. And then we say, well, out of those outcomes, what percentage of them involved me getting the two-sided coin? Well, if we look here, all of these, edit. If we look at it here, this is the area out of the yellow where I had the two-sided coin and I got the 5 out of 5. And so this is going to be roughly 32 out of 41 of the yellow, of this yellow area. So that's a visual representation of Bayes' theorem. This says the probability of getting a two-sided coin given I got 5 out of 5. That says, well, okay, let's look at the universe of you got 5 out of 5. And then what percentage of that universe involved you getting essentially the two-sided coin? And that's that. And that's all Bayes' theorem essentially tells us. So let's see if we can apply that. Let's do it a more interesting one. Let's say, actually, I'm going to leave it there, and then in the next video I will apply Bayes' theorem to more interesting problems. See you soon.